guys, we've made it. It's the end of Chapter 10. You mostly did Chapter 10 using the other textbook and all those classwork activities that we had, but we're going back to the book. We're going back to the book for this to prove that you, my friend, can do all these problems in the book too, and you have a good understanding of this and probably better that you did those other assignments, I'm hoping, than if we just had stuck and chugged along with the book. So again, I hope that this was a chapter of experience for you. You maybe built some shapes, you watched the videos, you attempted some different things that wasn't just kind of going and trying problems on the textbook. You'll be able to do these things too, but the reason why we're doing them is because there are a lot of good practice, right? A lot of plug and chug numbers in this chapter, which you haven't done a ton of yet. So that being said, you do want to have two things out, really two additional things that you might not always have out every single time. First thing, have a calculator out. So I don't say this out loud enough, but pretty much always, right? Anytime you have an assignment in math class, you have your calculator out. This is an extension of your hand in math class is your calculator, because you want to save that brain power for kind of thinking through problems and the things that, a calculator can't do for you, which is like read the problem and figure out what to do with them, what formula to use, for instance. So save the calculator for computation, and then you're the decision maker as you're going through assignments. On the note about formulas and choosing the right formulas, another thing I want you to have out is that toolkit you were working on all chapter long. So you should have all the formulas now for prisms and pyramids and cylinders and cones and spheres and all that jazz, all that good stuff. You should have that and have that on your toolkit, because you got basically about 2 to 3 formulas for each one of those shapes. So you do that, you multiply that by about 5 different types of solids that we have. That's a decent amount of formulas, right? That's over 10 formulas that you should have at this point in your practice of working with solids. So have your toolkits out. That'll make your lives a lot easier, especially looking at these next few problems in self-test number 1. It's a lot of computation, getting lateral area, total area, and volume. So what we're going to do today, we're going to do the Thursday assignments, May 14th. You're going to see me just go along and do them with you, one after another. So you get to see how long it'll take Mr. Fortin to do them and explain them all. So self-test 1, which is page 442, numbers 1 through 8. And then finally, we'll do together, right? We can do self-test 2, page 457, numbers 1 through 6. And then on Friday, you're going to make sure you know all this stuff, and you're going to do the chapter test, okay, which is number 1 through 16. And a bit of a chapter review every 4 problems or so. So I think I just have listed here 1, 4, 8, 12, 16 to 20, just because those we'll have available, and we'll review those in the following Monday. And then we'll move onward. We'll go on to coordinate geometry with some good stuff. Okay, so let's get into it now. California. Question number 1, we're just looking at a rectangular solid. So what they mean there is a rectangular base pyramid. So notice, right, a rectangular base pyramid, we could have chosen any of these pairs of corresponding sides, such as this and the one back here as the bases. So we could have chosen those as the bases, and then these 4 would be our lateral surfaces, or we could have chosen, for instance, this side to be a base, and then this side would be the other base. And then 1, 2, 3, 4 to be our lateral surfaces. So in the book here, they just call this a rectangular solid. If you have a rectangular prism, it's just the only way you can create a 6-sided rectangular solid is that it ends up being a prism. So that's why they call this a solid there. And it's not really a big deal that you understand the distinction or not. When I read that, I was like, oh, I've never really heard that entirely, but I can reason through it. Okay, anyways, as length 10, width 8, and height of 4.5, let's go ahead and get started with the volume, right? It's just length times width times height, so you can save that from your middle school days. But of course, it's really just the base area times by the height. 8 times 10 is 80. And we'll multiply that by 4.5. I got my calculator going. I doubt you can hear me hitting the buttons, but I got 360 for the volume. Nice thing is they didn't have units, so you don't have to put units down too. So you have 360 here. Lateral area, well, it really depends on what you choose as your basis. Hey, let's choose this one as our base. Okay, so let's get this with 8. So let's have the little guys be this here. So let's do 4.5. You can really assign these dimensions anywhere. 4.5, and then width is 8. So base area We won't include the base areas, but let's get the perimeter of this. Okay, so remember, if this is a rectangular solid, then it's going to be right angles, a whole bunch of right angles, because there's a whole bunch of rectangles. So we don't have any obliqueness going on, because then the lateral surfaces would be non-rectangular parallelograms. So we're able to use, because this would have to be a right prism, because you got all those rectangles dealing with here. We can use the formula for lateral area. We can use the formula lateral area is equal to perimeter of the base times by the height. Okay, so perimeter of base here looks like it's 4.5 here is here, and then 8 is here. So the perimeter of the base looks like it's 16 plus 9, which is 25. And then the height of this, the length here is 10. That's the longest edge, so I decided just to label it based on how it's kind of drawn. And then that's times by 8. So my lateral surface area, I get 2 hundo for that. Total area, okay, so we just need to add on the 2 bases. So 2 bases, because we have a base here, we have a base back here. And for prisms, right, a rectangular solid, we would have 2 bases and 4 lateral surfaces. So we'll just have to add that to the lateral area. Okay, area of 2 bases is going to be, well, 4.5 times by 8. Let's do that in our heads real quick. So that would be 36 times 2. So 2 times by 36 plus 200. And I get 272. I'll have to check my answers afterwards and then report back to you if we made any mistakes. But also keep an eye out for them in case I'm making mistakes. Number 2, let's go into it. A regular square pyramid with a base edge 24 and a slant height 13. Okay, so that's going to make volume a little bit more complicated, so we'll get to that afterwards. So why don't we start with the lateral area first? We have a slant height, which is nice, and it's a regular square pyramid, so we are able to use some shortcuts here. And the base edge is 24. And the lateral area of a regular square pyramid, remember regular pyramids have each edge of the base is congruent. So it's a regular polygon in the base, and then also the apex is directly above the center of that regular polygon. So we're able to use a shortcut, which is that the lateral area is going to be the perimeter, right, which is 24 times by 4, which is 96. And then we're going to multiply that to the slant height. So the shortcut for lateral area is that we're going to take 1/2 the perimeter and multiply that times the slant height, because each of these triangles would be 1/2 base times by height. And remember that the slant height gets its own letter to it that we're not used to seeing here. It is L. So 1/2 24 times IL would be that area, and then 1/2 24 times L would be that area, and so on and so forth. So we can just add all those bases together, right, the base edges, and that would be 4 times 24, which is 96. And we're going to multiply that by L, which is given to us here as 13. Do some quick mental math in order to save the numbers we need to put in our calculator. 1/2 times 96, well, half of 96 is going to be 48. And I'm going to multiply that by 13 to get to my answer. And here you hear my calculator hitting buttons, and I get 624. No units means I don't have to put units in my answer. So this is just a relative lateral area based on how the edge and slant height were assigned values. Total area, we need to get that, add that base area to it. So there's only one base in a pyramid, so we're going to add that to 624 because that was our lateral area. So base area, and here is just 24 squared, which is 576. Add it to 624. And how about that? Nice and cleanly, that would add in our calculators to 1200. Sorry you can't see my calculator as we're doing this. So let's talk volume now, right? Let's talk volume. Regular square pyramid. Okay, let's start with one thing. Let's start with getting our formula in here. Okay, I'm going to put H over here first, and then I'm going to switch back colors. So the volume of a regular square pyramid is 1/3 base times height. 1/3 base times height. This is actually a quick tip here. Actually, when you're doing problems like this, it might help just to write down what all the volume formulas are right away. Because remember, you can use volume formulas for any given solid within that set of solids. Meaning for any pyramid, you can use the volume of a pyramid formula. For any cylinder, you can use the volume of a cylinder formula. For any prism, you can use the volume of a prism formula, and any cone, you can write the volume of a cone formula in. So a cone and prisms, right, they could be oblique, but that doesn't affect volume because of Cavalieri's principle. Remember, we slide those layers, those cross sections over those areas, and then they'd still fill up the same volume if the height doesn't change. Obliqueness doesn't matter, but that would affect total area and lateral area. It's like that, okay? So one tip on that is just to write down your formula ahead of time. Okay, what part of this formula haven't we figured out yet? Okay, well, we figured out B, base area. Yes, we did. We used that in the last formula. Have we figured out H? Well, we know what L is. We know what P is. Those are the only variables we've figured out in these formulas. So we need to figure out what H is. So how do we do that? How do we do that, guys? H. Okay, so H stands for not the slant height. It just stands for the height of the solid. And if this is a regular square pyramid, this is the altitude that goes directly to the center of the pyramid, the centers of the pyramid's base. So this is a little bit tricky. We didn't really have to do this too much in the classwork, but we need to figure out what H is. And do we know what L is? Yeah, we know what L. L is 13. And we're hoping this is kind of a special right triangle, and indeed it's going to be a special right triangle, because if L is 13 here, do we know what this distance is? Well, let's see here. What kind of a base is this? This is the center of the base. Oh, the base is a square. Okay, this is the center of a square. So we know that a square, the center of it, right, this would get divided. If I do this, this would be 4 congruent squares in the middle. So this distance here, what this leg on this right triangle must be 12, because that is half of 24. The center of a square is halfway between the bases. And half of the base edge would be 12. And so then now we have a right triangle. We have 13 here, we have 12 here, and that means the height of this pyramid has to be 5. So we'll use that within our formula. So height is 5, base area we'd gotten earlier, and that was 576, because that's just 24 squared. And we'll multiply that all in our calculator now. 1/3 times by 576 times by 5, and I get 960. Moving on, we're grooving. Let's see if we can go a little bit faster on these, right? Am I going too fast? Am I going too slow? I don't know. This is the point of this video, is I'm going to share the time that I'm working on each problem. So you don't need to watch the whole thing, but feel free to if you'd like. Pick and choose which problems to watch. A cylinder with radius 10 and height 7. Okay, so we got a diagram right now here. It's pretty easy, right? We got 10, height is 7. So it says cylinder. Did it say anything here? Okay, so we don't know if it's oblique or not. So let's assume it's right, I guess. Assume it's a right cylinder, and that's important because it need to be a right cylinder in order to use the formula for lateral area, which is going to be 2 pi r h. 2 pi r h, because remember, for lateral area, we have h is the height, and if we unfurled this whole thing, we'd have to go 2 pi r around. This is the circumference of the base, would be the base of a rectangular wrapper or something like that. That would be on here. 2 pi r times by h would be the formula there. Okay, so let's assume this is a right cylinder. If it were a real test, we'd probably just write in, we can't assume this because we don't know if it's oblique or not, right? If it were oblique, if it were tilted over, then it would be a different shape. It wouldn't be a rectangle once you cut it open. And this would be, so let's get the answer, 2 pi, radius is 10, height is 7, and we get 140 pi. Total area, we got to add the base area to that, and the base area is just going to be pi r squared. So let's get 2 of those, right? Because we need 2 bases, 2 pi r squared, and then we're going to add the lateral area to it. So we got 140 pi and then 2 pi r squared. So pi r squared is going to be 1 base, so that would be 100 pi, because 10 squared is 100, so 100 pi times 2 is 200 pi. So we got 200 pi, and we're going to add that to 140 pi. So we get 340 pi for this one right here. Moving on. Finally, we've gotten to volume. This is the same thing as the prism before it. Right? 3 times what the pyramid is, because we got the base area times by height. And pi r squared we've already calculated. That was 100 pi. Times by h is 7, so let's just write the answer in. 700 pi as our answer to this one. Let's keep moving. Drilling Killer, I didn't want to just sit around and just do problems like these again and again and again for like 2 weeks, guys. How boring would that have been for Mr. Fortin? I don't care about you guys. I just want to make things interesting for me, right? I want to build shapes and stuff. I don't want to do this stuff with my life. Anyway, right hexagonal prism with height 5 and base edge of 6 centimeters. Again, we're going to assume that this is regular, a regular base, because it's possible you could have a right prism where the sides are different lengths. It's just the angle where the lateral edges are meeting are still right angles. So we're assuming it's regular so that we can actually figure out the area of the base and use formulas. So let's get the volume of this. It's a prism, so it's just the base area times height. Base area here, we can do this on top. Base edge is 6. So that means the radius of this, and we would multiply that by 3 root 3. So 18 times by 3, and here's where I'm just going to be faster doing my calculator. And it's a pretty easy calculation. 18 times 3 is 54, so I get 54 root 3, and we'll multiply that by the height, and it gave that to us, luckily, which is 5. Again, I could just do that in my head, but why do that? Save my brain power for decision making, not computation, right? Computers are good for one thing, humans are good for other things. Right? We get our volume there, okay? Use your brain power to double check your answer. I'm not going to spend time doing that now. I'll just check them afterwards. That's where I want to use my brain power. Just check the answer key in the book. If we're a test, right, you'd have to practice actually checking it yourself. Okay, lateral area. Well, we got to get it's right. So now we can definitely use this formula. So we can use perimeter times by height, which is nice. So we assume that it's regular. So we assume that the perimeter is 36. And the height, these make all rectangles here if these are right, so we just have to do 6 times by the height again and again and again, so might as well take the perimeter. 36 times by 5, and that's going to be, what, 150, 180, so that I can do in my head without expending too much effort. So 180 for lateral area, and finally total area, we just have to add 2 of the base areas to this, plus that lateral area, and we have that all written right here. We have the base area is 54 root 3, so this will be a bigger number because base area it's an irrational number, has a square root symbol right here. So we got 2 of those. So let's make it 108 root 3 plus 180. And that's as simple as you can write that exact answer. You could convert to an approximate decimal answer if you wanted to, but why do that? That's the exact answer. That's the better answer. All right, we're moving 4 out of the first 5 of these questions here are done. So let's turn our attention to the cone down here. That has a height of 12, and I'll draw that in, and a radius of 9. Now, I'm assuming that this is a right cone. Again, they didn't tell us that, but it's a right cone. But if they're telling us the height, they probably mean the perpendicular distance from the apex, and that's probably going to meet in the middle of the circle. If it's not a right cone, then we don't know how to get the lateral area, and therefore getting total area will be hard. We can still get the volume, but the first 2 things they asked for, we wouldn't be able to find, okay? Wait, I noticed a big error. I made a classic mistake here. Just notice here, the volume formula. So I remember I told you before starting, you might as well just write down the formulas. That way you can notice, you can relook at this and make sure you wrote them down correctly. I didn't write this one down correctly. This should have been volume was 1/3, not 1/2. Remember, it's in a 1:3 ratio with the cylinder volume formula, which is pi r squared h. So this should be 1/3 pi r squared. Ooh, I missed the h here too. So there should have been an h down there. Okay, h down there. So that being said, getting volume is pretty easy. Hey, let's save the volume for later because we already know the radius, we have the height, we can just plug and chug and get our answer there. But the harder thing is actually going to be at the lateral area of this right cone. So remember the lateral area? Lateral area had kind of a formula to it. And that had to do with, instead of dealing with the height, remember lateral area here is kind of similar to a lateral area of a pyramid. With pyramid, you don't care about height, you care about L. You care about the slant height. Remember, the slant height determines the altitude of the triangles here, and the slant height is going to kind of be the best indication of the size of, well, if we cut this open, remember if we cut this open, what type of shape did it make? Do you guys remember that? Let's just quickly re-go over this proof in maybe like 2 or 3 minutes here. All right, so if we cut this open, cut the lateral surface open, and we unfurled it, should be able to remember this from earlier in the chapter. If not, you got to go back and rewatch this lesson. If we unfurled this cone, so I'm turning the cone kind of on its side here and putting it onto a plane. If I cut down here, right, this is the slant height. then this is the slant height here. And I unfurled the side, right? And then this would be all of this circumference down here. If I went all the way around and laid it out, right, this would be the apex right here, and then this would be the circumference. So this actually down here would represent 2 pi r, the 2 pi r circumference of the base of this cone. This would be a sector. Remember this was a sector with a radius L and a arc length of 2 pi r. And so remember this, we found the formula for this by using the area of a sector formula, right? So here's our cone, right? Cone's right here. And this would be part of a larger circle that we don't really care about, but I just care about this to prove what the lateral area of a right cone is going to be. And by using the area of a sector formula, which is theta over 360, which is really just talking about what percentage of the 360 degrees would be taken up by this here, times by pi r squared. We use this to kind of get to the area of what this guy is, right? What the sector is, and therefore what the lateral surface is of this greater circle right here, greater circle. So remember how to do this. Let's just quickly, briefly remind you guys on how we did this one here. Well, first things first is this sector, right, which is, again, the lateral surface area of the cone. We had to figure out what percentage, right, what ratio of this sector it was to this overall circle. So we had to set up one ratio, and the first ratio I'll write here is, well, this would be in a 2 pi r. Remember, an r is defined by the radius of the base of the cone, okay, because this is circumference right here, so this is 2 pi r. It was 2 pi r to the circumference of this larger circle right here, which we have in purple, and I'm changing to black right here. Okay, what's the circumference of this larger circle in terms of the problem? Did we use r? Did we use the radius of this base to get the circumference of this larger circle? No, we use L. Actually, we use L. So this is 2 pi r over 2 pi L. And so this is the ratio of this sector to the larger circle. Then we need to multiply that to the area of this larger circle so that we can figure out what would this area be represented by in terms of L, in terms of r, right, which we have there, in terms of pi, of course. Pi is definitely the same remainder. So we're going to multiply that by pi r squared. But are we going to use r squared, or are we going to use something else? Well, what's the radius of this circle here, the one that we're using with the cone's surface as the sector? Oh, that's right, the radius is L. So we're going to multiply this by pi L squared. And remember this is how we prove this here. We have 2 pi over 2 pi, those cancel out. Now we have R over L, those wouldn't cancel out. But L squared over L would cancel out one of the L's, and we'd be left with R pi L. Or the way this is typically shown in formulas is pi RL. And that's how this one gets proven. And are you going to remember that proof perfectly? Probably not. But hopefully you kind of remember that the lateral surface of a cone is a sector. And that's kind of how you can prove it, right? You can prove and get through it. So this one's more the ones where if you sit down and actually read the proof again, you'd understand the logic. And that's the reason why I go through with you right now. Okay, so let's get this one done. Lateral area of a right cone. We got height 12, radius is 9. We don't care about the height again. We care about what the slant height is. Ooh, we haven't even actually figured that one out yet. But what is it? So slant height it could be on either side, or it could be anywhere really on this cone, as long as it's from the apex to a point perpendicular on the base. So one of the perpendiculars drawn. So that means that this is a slant height here. And this is helpful because it looks like this is a hypotenuse on a 9, 12, 15 right triangle. So a 9, 12, 15 right triangle, right? This is in the ratio 3, 4, 5. So this would be a Pythagorean triple. Pythagorean triple right here. So let's go ahead and put 15 in for L. And then we had radius was 9. And we have pi. So we can get this all figured out. This is something that I can do in my head. 9 times 10 is 90. 9 times 5 is 45. So we get 135 pi for the lateral area of this cone. Total area is, we're going to have to take the base area and add it to that 135 pi. So our base area is going to be 9 squared, which is 81, and then multiply that to 135. So we can do that in our heads too. which is 216 pi. And finally, we get back to the volume, right? And this was just simply, we got to input right here. Volume is going to equal 1/3 pi, and then we have r squared, so the base area, times by the height. So r squared again is 9, and then we got to square it, times by the height, which is 12, not 15 like I'm writing down here. 12 is the height. 15 is the slant height. I should have done 12. So we're doing, right, this is going to be 81 right here. And 81 divided by 3 is going to be 27. So we got pi times by 27 times by 15. And at this point, this is when I would go to my calculator, because I don't want to do that in my head. I should be multiplying 27 by 12 by pi, thus getting the correct answer of 324 pi. Okay, all done with those 5. So those are the 5 kind of plug and chug, getting the lateral area, total area, and volume of those particular solids. So if you're doing well on those, you're in great position. Now is some more kind of comparison type things and other kind of thinking outside the box type problems. Question 8, a prism with height 2 and a pyramid with height 5 have congruent triangular bases, which has greater volume. Ooh, I don't have a diagram of this one right here. A prism with height 2 and a pyramid with height 5 have congruent triangular bases, which has greater volume. Okay, so I don't need a diagram for this one because this is simply a comparison one. And a prism with a height 2 and a pyramid with height 5 have congruent triangular bases. Remember, the area, the formula for this is volume equals base area times by height, and this one right here is volume equals 1/3 base area times by height. So if we know that the base areas are the same, then we can ignore the base areas here, and we can ignore this base area right here. So this volume of the prism is just going to be whatever its height is going to be 2 times by the base, whatever. And this one here is 5 right here. So this would be a 2 to 5/3 comparison. So because the volume here is going to be 2 times whatever the base is here, and the volume over here is going to be 5/3 times whatever the base is here, and these two bases are equal. Right? If you take equal values and multiply 1 by 2, this is going to be greater than if you have an equal base right here, and you multiply it by 5, multiply it by 1/3, it's not going to get as big. 5/3 is 1 2/3, and 1 2/3 is smaller than 2. So this guy is the one that has the greater volume, the prism. And this would be in a 6:5 ratio, because 2/2, another way we could have written that is 6/3. And that's definitely clearly bigger than 5/3. All right, first one down. That was trickier than I expected. So this video is probably a bit longer than I was hoping for or expecting, but I'm pretty confident in these explanations, so hopefully they help somebody out there. Hey, self-test 2. Find the area and volume of a sphere with a diameter of 6 centimeters. Hey, that seems easy enough. We know that. We know the formulas. Again, let's get them down. So area formulas. Remember, A for area. Area is a two-dimensional calculation, so we know with spheres, that's going to be squared. We're going to have r squared right here. And remember, 4 is part of the coefficient, but we're not going to put 4/3 because we have this 2 right here. That's the shortcut to remember what's the surface area of a sphere formula, is that no 3's appear in it. No 3's appear in it. For the volume, 3's appear in it because the way you can remember it is that volume is a three-dimensional calculation. So you're going to have pi r cubed. You got r, right? R measures the width, it measures the height, and it measures the depth of this here. So you have r being cubed there. Okay? So this is a simple plug and chug type problem, except they mentioned diameter, so we got to make sure we're right about this, that this is 3 centimeters as the radius, and this is going to be 4 pi times by 3 squared. And let's do them both together. This is going to be 4/3 pi times by 3 cubed. One thing we can do here is that we can cancel out this 3 and change this to 3 squared. We can remove one of those 3 factors within that exponential expression over here. And then this is going to end up being 9, and 9 times 4 is 36. So this is 36 pi for area. square centimeters because they gave us units to use on this one. And this one over here is going to be 3 squared is 9. And again, oh, look at this. This is actually going to be 36 pi cubic centimeters. So very nice. Kind of worked out the same right there, but completely different because this is square centimeters and this is cubic centimeters. So this fills up space, this fills up the plane. The volume of a sphere is 32 over 3 pi. Find the area. Okay, there you go. So this is one of these ones where we have volume, and it's going to have us practice that formula, but they gave us the volume, and that's going to help us determine what the radius is of this particular sphere, because they gave us that volume of 32 over 3 pi. So one of the benefits of writing out the formula is you see I have an input there. I can put it in, even though v looks like kind of our dependent variable here. We can still put it in, and we can solve for this other input that we don't know what the answer is to it, which is the r. This one here, all right, let's start simplifying down to get what r is in this situation. I would start by multiplying by the reciprocal of the coefficient. So by multiplying by 3 over 4, both sides, and lovely, 3 divided by 3 is 1, and then 32 over 4 is 8. So on the left side, I'm going to have 8 pi. And on the right side, the whole point of multiplying by the reciprocal is so we can cancel out the coefficient, and that's going to be pi r cubed. And then lovely. We're going to get a nice clean answer in a second, because if we have pi as a factor over here and pi as a factor over here, we can divide both sides by pi and eliminate those. So now I have r cubed is equal to 8. So if I take the cube root of both sides, I would get 2 is equal to r. Cube root of 8 is 2, and then that would be equal to r. So there's our radius of this sphere right here. We need to find the area. So let's practice that here. Area is a 2-dimensional calculation. So we have r squared, and then we don't have to worry about any 3, so we just have a 4 in front. Remember, the area formula for a sphere is just 4 times the amount of area that the great circle of the sphere contains. So this is just going to be r squared is going to be 4, and 4 times 4 is 16, and we have that 16 number again, 16 pi. Number 3, the students of a school decide to bury a time capsule consisting of a cylinder capped by 2 hemispheres. Find the volume of the time capsule shown. So it looks like we have 2 hemispheres here, and as you remember from that video, I know you watched it, right? You watched the volume of a sphere lesson, and that also had the surface area of a sphere. We watched that one. We used the volume of 2 hemispheres to pour into a cylinder of equal height as the sphere. And remember, I was just doing that to approximate. I can't use just the whole sphere to fill up with water. It's not going to work. I got to use 10 hemispheres. So basically the idea of this here is we want to figure out what the volume is of one sphere of a radius, you guessed it, 10 centimeters. We figure out one sphere, so we don't need to do a hemisphere. Like 2 hemispheres just equals 1 sphere. So we need to figure out the volume of a sphere of radius of 10 centimeters. So let's do that right now. Let's get that one first. So this is 4 over 3, and r is 10 centimeters, and we're going to cube that. Okay, this is 1,000, and so this would be 4,000 over 3, it looks like. Get pi on there. That's the volume of the sphere, or the sum of the 2 hemispheres in that time capsule. So now we just need to get the cylinder. It would have the same radius, and we know the height, so this should be easy enough. So 60 times 100 is going to be 6,000. So the volume of the capsule is going to be the sum of those 1, 2, 3 regions. And 6,000 pi, I'm going to make that over 3. So 18,000 pi divided by 3 would be equivalent to that. And we're just going to add that to 4,000 pi. And I do that so that we can get a nice clean answer where we really only have one term we're looking at here. So this is 22,000 pi over 3. Question 4, find the area of a circle formed when a plane passes 12 centimeters from the center of a sphere with a radius of 13 centimeters. Hey, we did this in class recently. This was part of the Kahoot. So we have a sphere. If a plane touches a sphere in more than one point, meaning a plane's not tangent to its sphere, but it intersects a sphere, it's going to intersect the sphere in a circle. So the points in common on the plane and then the exterior of the sphere would make up a circle right here. So we can use the fact that the sphere is the set of points that's equidistant from a center point. So from the center is 12 centimeters away from the plane, and distance is measured as the perpendicular. And let's just put this here for now. So this is 12 centimeters, and we can use that thing where the radius of the sphere is going to be 13 centimeters here. So now all of a sudden we have a right triangle with a leg's 12, a hypotenuse is 13, and this radius of the circle. So this here is the circle that is formed by the plane intersecting the sphere. And it would have a radius 5, and that means the area would be pi r squared, which is 25 pi. And that was a tricky one on the Kahoot the other day. Boom. Question 5. One regular triangular pyramid has a base edge 8 and a height 6. A similar pyramid has a height 4. Find the base edge of the smaller pyramid. Find the ratio of the total areas. Very nice. All right, so let's mark it up. Base edge is 8 here. Height is 6. This height is 4. Okay, so what they're showing us here is that the linear scale factor is 3 to 2. So that means that this must be in a 3 to 2 ratio. The edges of the bases need to be in a 3 to 2 ratio as well. So the way I'm going to do that is I'm going to use a little cross multiplication here. So I'm going to do x over 8 equals 2 to 3, because x to 8 needs to be in a 2 to 3 ratio with x. And then here, cross multiply, I get 16 here, I get 3x here. So x is going to equal 16 over 3. And I'll write that as a mixed number up top here. So that would be 5 and 1/3 would have to be the base edge here for this to be in a 2 to 3 ratio. So go from here to there. Find the ratio of the total areas. Well, if the linear scale factor is 3 to 2, then the area ratio will just be the square of that. So that is 9 to 4. And I don't think there's anything else to say about that one. What would the volume ratio be? All right, it would be 27 to 8. It would be the cube of the linear scale factor. And we might get to this in the last problem. Very nice. This is our very last problem. And this one we did in the Kahoot, so hopefully try it again now. This one was definitely one of the harder ones when you did it in the Kahoot last Monday. But maybe you did it now, maybe you're successful. If not, we'll go over it one more time. The base areas of two similar prisms are 32 and 200 respectively. Okay, so it looks like they're telling us about the area ratio. And I remember when I explained it to you guys, that would just be the square of the scale factor. So this would be 200 over 32. And if you look at these numbers, you'll notice that 8 goes into both of those numbers. So 200 divided by 8 is 25, and 32 divided by 8 is 4. And that's nice because both of those numbers are perfect squares. And the next thing that I would do in this problem, even without reading the rest, is that everything's going to come from the linear scale factor. And if 25 over 4 represents the square of the linear scale factor, and k is usually the variable to show that, you would just need to take the square root of this here. So the square root of 25 over 4 is going to be what's going to get us to k, which is 5 over 2. And since their heights are a linear measurement, right, that's just a one-dimensional measurement, it's just going to be a 5. Or I'm going to do 2 to 5 ratio, right, because they're very small to big. So part B, find the ratio of their volumes. Well, that we need to get the volume ratio, and that's just going to be the cube of the linear scale factor, because in order to get volumes, you need to find 3 dimensions worth of ratio action here. And so if they're all in a 5-to-2 ratio, you just need 5-to-2 times 5-to-2 times 5-to-2, and you would get k cubed, and that would equal 125 over 8 would be that ratio. And we'll write it up here and get our answer. Okie dokie, guys. I definitely noticed that was probably a little bit harder than I was expecting. So there it is, a whole bunch of questions in the same place. We did a bunch of the classwork and we sort of gave background to it. Just having sat here and just having done a whole bunch of problems for a couple weeks, say if we had just done the textbook, I don't think it would have gone much easier. In fact, I think the textbook would have been a little more frustrating to do. So anyways, hopefully you got practice now. You have the textbook if you want more practice, but there'll be more practice coming up. And that'll be on Friday, right, tomorrow. So hopefully you didn't spend too much time on this and save some energy, because what you need to do is this tomorrow, Friday's assignments, chapter test, number 1 through 16 all. And my guess is that these probably won't be as crazy, although there will be some challenging ones, I'm sure. And then chapter review after that. Save some energy in 1 through 16, because then you're going to do every 4. 1, 4, 8, 12. And then 16 and 20, finally, I just have you do these last ones here because I want to make sure you know how to do these problems, which we had a similar do now to this. Okay, guys, that's it. Hopefully this helped answer some of your questions. If not, email me about some of these specific problems or anything else you need help with. Bye, guys.
I hear the drums echoing tonight, but she hears only whispers of some quiet conversation. She's coming in 12:30 flight. The moonlit wings reflect the stars that guide me towards salvation. I stopped an old man along the way, hoping to find some old forgotten words or ancient melodies. He turned to me as if to say, "Hurry, boy, it's waiting there for you." What's right, sure as Kilimanjaro rises like Olympus above the Serengeti. I seek to cure what's deep inside, frightened of this thing that I've become. It's gonna take a lot to drag me away from you. There's nothing that 100